Hello and welcome everyone. In this video, we are going to talk about the process life cycle. Now, as we discussed earlier, there are different states of the process. The process can be in the new state, ready state, running, waiting, blocked, terminated, etc. So let's understand how does this process life cycle work. So let's say that you've written a program, and at the time when you write the program, it goes to the secondary memory, let's say hard disk, where your process is created. So at this point, the process is not executing. It just created it, just staying there inside of the secondary memory. So what happens is that the process goes from the new state to the ready state, which means it goes into the queue and it's ready for to be executed. It's still not executing at this point, but it is ready for the execution. And this whole area that you see, this is basically your RAM. Okay, and then on the left hand side that you see this circular dots, this is your secondary memory. So this is your primary memory, this is your secondary memory. Okay, so the process from the new state goes to the ready state. So it comes to the primary memory, it comes to the RAM, and this task of moving the process from new to ready state is done by long-term scheduler, LTS. Okay, and it follows multiprogramming, which is the increasing as many processes as possible to make sure we have the optimum CPU utilization. Okay, so multiprogramming is the number of processes at a given time, available at a given time. Okay, so long-term scheduler moves the process from a new state to the ready state, and then from this point, when it needs to get executed, then the short-term scheduler dispatches or schedules the process, which means that the CPU is assigned to this particular process. So it goes on in the running state, it goes in the execution mode, so it starts executing. So the CPU at this point starts executing the program. Okay, and once it finishes its execution, then the program is terminated, and whatever the resources were allocated to that program, those resources are then released. Okay, so that's your standard process, and the job of long-term scheduler is to move the program from a new state to ready state. Short-term scheduler moves it from ready state to running state. Okay, now there could be a scenario wherein another process comes in which has a higher priority, or for instance, that particular process has a time limit. So that's what the meaning of time quantum is, that it has a specific time limit. It's supposed to run only for a specific time. Okay, so when that time finishes, then it goes back into the ready queue. Or if there's another program that comes in which has a higher priority, then that particular process is going to be put back into the ready queue, and the program that has a higher priority starts getting executed. So the CPU is assigned to that next program which is a higher priority. So once this finishes, the next program finishes execution, then we put the previous program back into the running mode. Okay, so that's one way of interruption. So the interruption could happen because another program came in with a higher priority. So let's say A was executing at that time, it was in a running state. Another process B came into existence which has a higher priority. So the A stops executing at that point, goes into the ready queue, and B starts executing because it has a higher priority. Okay, so that's your interruption. And in case there could be a scenario wherein the process itself says that it needs an input output request. Okay, so it is executing at that point, it is running, but then during the execution it is observed that it has an input output request without which it cannot proceed further with this execution. So what happens in that case? It goes in the waiting or blocked queue, because it's blocked at that point. It's waiting for the input output operation. So that program goes into the waiting queue. Once it's received the input output, once its input output request is complete, it goes back to the ready queue, and then from the ready queue it will go into the running state. So once it's blocked, of course other processes are going to come in, and CPU will be assigned to those processes. So once the previous process input output is complete, request is complete, then even if it comes in the ready queue, it cannot be executed at that point because there will be other process that will be executing at that point. That's why it goes in the queue, and whenever its turn comes, it goes back into the running. Okay, so in a nutshell, basically, if a program is executing and it has an input output request, it goes into the waiting queue, and once the input output request is fulfilled, then it goes back to the ready queue, and from there it'll go to the running queue once the CPU becomes available. Okay, so that's your process of waiting and blocked. There could also be another scenario wherein there are multiple programs that are coming in the running state, and majority of them have the input output requests, which means majority of the program are actually going into the waiting queue, and this queue will get filled because RAM has a limited memory, so those frames in the memory can be filled. So if it's completely full, at that point it goes into the suspended mode. Okay, so it goes in the suspended wait, and at that point, because we don't have enough memory, it is sent back to the secondary memory, and it said that once you've got your input output request complete, then you can come back and go back to the waiting queue, and if the space is available. Otherwise you can stay in the secondary memory. We don't have the space available for you, and this job is handled by the medium term scheduler. So medium term scheduler sends the process to the secondary memory when we don't have enough space available in the primary memory. All right, so I hope that's understood about the process lifecycle. And there are different types of schedulers, as I've just explained to you, so let's just go over them quickly. So we discussed about the long-term scheduler, which brings as many processes as possible from the new to ready state, from secondary memory to primary memory, using the degree of programming, which is bring as many processes as possible into the primary memory. And then we have the short-term scheduler, which brings the process from ready queue or ready state to the running state. And then we have the medium-term scheduler, which basically says that when the RAM does not have enough memory, or when the primary memory does not have enough memory left in the waiting or blocking queue, the medium-term scheduler sends the process to the secondary memory because probably this process was blocked because of IO request. All right, so this is just a summary of what we discussed in the previous example, the long-term scheduler, the short-term scheduler, and the medium-term scheduler, about what all they do. All right, thank you.